Hello everyone, I am Umair and you are watching Chemistry Guides. In this video, we will discuss about F-block elements MCQs. Here is the MCQs number 1. The element in which the additional electron enters n-2 f orbitals are called S-block elements, P-block elements, F-block elements, none of these. So what the right answer is actually F-block elements. If we go into the detail of this MCQs, we will find that from atomic number 57, lanthanum. So here we can see that the electron enter in D block element, and further if we go downwards, the electron enters in the F block elements. So that's why they are called F block elements. MCQs number 2 is the 4F block elements are also called lanthanides, lanthanons, rare earths, all of these. So the right answer is all of these. So why they are called all of these? First, why they are called lanthanides? Lanthanides is actually the series of 15 metallic elements from lanthanum to lutetium in the periodic table from atomic number 57 to 71. Why they are called lanthanons? Because the elements the F block elements are also called inner transition elements because they contain partially filled 4F subshells. They are also called lanthanides or lanthanons because they have a close similarity with the element lanthanum. Further, they are called rare earth metals because they are rarely found in earth crust. MCQ number 3 is how many elements are members of lanthanides? 12, 13, 14, 15. So the right answer is 15. If we go into the detail of this MCQs, we will observe that this is a list of lanthanide series, and the number of elements in this series are 15 is 15. MCQ number 4, which of the following are important minerals of lanthanides? Monazite, oxenite, xenotime, all of the above. So the right answer is all of the above. The detail of this MCQs is monazite. If we talk about monazite is actually contain 40 to 45 to 48% cerium. It also contains 24% lanthanum. Further, it contains 17% neodymium and 5% praseodymium, and it further has minor quantities of samarium, gadolinium, and yttrium. So these are the lanthanides or F block elements present in monazite. Further, if we talk about oxenite, the oxenite is also a mineral of lanthanides. Further, xenotine is also a mineral of lanthanides. Fifth MCQ is the percentage of cerium earths in monazite is 50 to 70%, 50 to 60%, 40 to 50%, or 30 to 40%. So the right answer is 50 to 70%. MCQs number 6 is the percentage of yttrium earths in zonotime is 50 to 60%, 40, 54 to 65%, 40 to 50%, 30 to 40%. So the right answer is 54 to 65%. MCQ number 7 is the location of significant deposits of lanthanides is USA, Brazil, South Africa, all of the above. The right answer is all the above. MCQ number 8. Which of the following is not the member of lanthanides? First is ND, LA, SM, and BA. So if we the right answer is BA. Barium is not the member of lanthanides. While if we see the detail of this MCQ, we will observe that in this list of lanthanide series, we will not find BA barium. So that's why this barium is not part of lanthanide series. MCQ number 9 is which of the following classical methods are used for separation of lanthanides? Fractional crystallization, fractional precipitation, fractional thermal decomposition, all the above. So the right answer is all the above. MCQ number 10 is which of the following modern methods are used for separation of lanthanides? TLC, ion exchange, complex formation, all the above. The right answer is all the above methods are modern methods which are used for the separation of lanthanides. Next, MCQ number 11. The common oxidation state of lanthanides is +1, +2, +3, +5. So the right answer is +3. The detail of this MCQs is, if we observe this list, we will find that almost all the elements except SM, all the elements contain oxidation state +3. So it is the most common oxidation state in the lanthanides. MCQ number 12. The +2 and +4 oxidation state is shown by which of the lanthanides? SM, C, ER, LU. So the right answer is SM. SM contain both +2 and +4 oxidation state. If we observe the detail, we will find that SM is the only element which contains +2 and +4 oxidation state, while +2 only is present in other two elements that are Nd and Eu, while the +4 is present in other elements like cerium, protactinium, Tb and Dy, but while +2 is also present in Tb and Yb, but only SM is the only element which have both +2 and +4 oxidation state. MCQ number 13. The lanthanide conduction is due to the decrease in electron affinity, ionic size, electronegativity, metallic character. So the right answer is ionic size. The detail of these MCQs, if we observe that, we will find that there is decrease in the size of from lanthanum to lutetium. Why this is? This is because the poor shielding of nuclear charge by 4f electrons. So because of this poor shielding of 4f electrons, the 6s electrons are actually drawn towards the nucleus, so that's why that results in the smaller atomic radius. MCQ number 14. The color of lanthanide is due to FF transition, DD transition, SP transition, none of the above. So the right answer is DD transition. If we observe what is DD transition, DD transition are actually the electronic transition that occur between the molecular orbitals that are mostly metal in character, specifically the orbitals that we think of as d orbitals of transition metal complex. So the transition of electrons from lower molecular orbitals to higher molecular orbitals result in DD transition, and this result in the appearance of color. MCQ number 15. The alloys of lanthanides are known as coinage metals, mish metals, precious metals, none of the above. The right answer is mish metals. What are mish metals? Mish metals is actually an alloy of rare earth metals. It is also called cerium mish metal or rare earth mish metal. Mish metal alloy actually contains 50% cerium, 25% lanthanum, 15% neodymium, and 10% other rare earth metals and iron. MCQ number 16. The lanthanides are used in paints, nuclear industry, abrasives, all the above. So the right answer is all the above. MCQ number 17. The elements in which extra electron enters 5f orbital of the n minus second main orbital are known as 5f block elements, actinides, actinones, all the above. So the right answer is all the above. These are actually the 5f block elements. Here you can observe that the additional electron is entering in the 5f orbital, so that's why we call them 5f block elements, actinides. Or MCQ number 18. Which of the following does not belong to actinides? BK, TB, ES, AM. So the right answer is TB. So if we observe the whole list of actinides, we will not find EB, TB. So that's why it is actually the not the part of actinides. Which of the following solvents are commonly used in the separation of actinides? Diethylether, hexone, TBP, all the above. So the right answer is all the above. Solvents are commonly used for the separation of actinides. MCQ number 20. Which of the following elements show maximum oxidation states among the actinides? Np, Pu, Am, all the above. So the right answer is all the above. If we observe the oxidation states, we will find that Np, Pu, and Am, these three elements have oxidation state from +3 to +7 in Np and Pu, while +2 to +6. So these three elements have five oxidation states. So that's why they contain maximum oxidation states. 21 MCQs. Which of the following elements show +2 oxidation state among the actinides? AC, TH, AM, U. So the right answer is AM. Only AM among these elements of actinides show +2 oxidation state. We can observe that +2 oxidation state is found in AM. It is also found in other elements, but among those elements that was part of the question, only AM, americium is the only element which have +2 oxidation state. Which of the following elements show only +4 oxidation states among the actinides? AC, TH, AM, U. So the right answer is TH. Only thorium has +4 oxidation state among these actinides. If we observe on the second thorium, it has +4 oxidation state, while others don't have +4 oxidation state. MCQ number 23. Which of the following elements show only +3 oxidation states among the following actinides? FM, TH, AM, U. So from these oxidation actinides, only FM has +3 oxidation state. Only if we find in the fermium, it has only +3 oxidation state, while other don't have +3 oxidation state. MCQ number 24. Which of the following elements show color spectra among the actinides? Np, Pu, uranium, all the above. So all the above elements show color spectra in the actinides, and the reason of this color spectra is D transition. Here we can observe these are the actinides that we have already mentioned. U, Np, and Pu, they all show color, so they have color spectra, while others don't have color spectra. And we can observe the frequency at which they show color. F block elements are also called gun metals, coinage metals, outer transition metals, inner transition metals. So F block elements are called inner transition metals. So MCQ number 26. Lanthanides have dash total elements and actinides have dash total elements. 14, 15, 14, 14, 15, 15, 15, 14. So they both have 15, 15 elements, and total there are actually 30 F block elements. MCQ number 27. The main oxidation state of lanthanides is +2, +3, +4, +2, and +3. So the right answer is +3. So the main oxidation state of lanthanides is +3. We have already observed this in previous MCQs. All the actinides are radioactive, very stable, non-radioactive, any one of above. So the all actinides are actually radioactive. MCQ number dash or 30. That or mostly contain the light lanthanides: monazite, xenotime, auxinite, all above. So monazite mostly contain light lanthanides. Dash or mostly contains the heavier lanthanides: monazite, xenotime, auxinite, all above. So xenotime mostly contain heavier lanthanides. Why they xenotime contain heavier lanthanides? It is actually chiefly source of yttrium and other heavy lanthanide metals such as dysprosium, ytterbium, erbium, and gadolinium. MCQ number 32. Which ore mostly contains fairly even distribution of lanthanides: monazite, xenotime, auxinite, all of the above. So the right answer is auxinite. The most common oxidation state of actinides is +2, +3, +4, +2, and +3. So the right answer is +3. Oxidation state is also common in actinide as well as lanthanides. The most common oxidation state of lanthanides other than +3, lanthanides have +1, +2, +4, +5, +2, +4, plus 2, plus 5. So the right answer is plus 2 and plus 4. These are the other common oxidation states of lanthanides. The most common oxidation state of actinides other than plus 3 is plus 1, plus 2, plus 4, plus 5, plus 6, plus 4, plus 5, plus 2, plus 5. So the right answer is plus 4, plus 5 and plus 6 are the other oxidation states of actinides other than plus 3. MCQ number 36. Which of the following has stronger tendency towards complex formation? Lanthanides, actinides, both, none. So the actinides have stronger tendency towards complex formation. Why? This is because actinides have stronger tendency to form complexes than lanthanides because of it has higher charges and smaller size of cations, while the result in higher charge density and high effective nuclear charge. These facilities actually find it easy for ligands to accept lone pair of electrons. Which block elements are more electropositive in modern periodic table? So S block, P block, D block, F block. So the right answer is S block. Is elements are more electropositive elements in periodic table. Here you can find the first two groups of elements are called S block elements, and while helium is also part of S block element. Which of block elements are less electropositive in modern periodic table? S, P, D, F. So the more less electropositive elements are P block elements. 13 to 18 yellow, the elements in yellow color are actually P block elements. They are less electropositive. MCQ number 39. Which block elements are transist between the more electropositive elements and less electropositive elements in modern periodic table? S block, P block, D block, F block. So the elements that transist between more electropositive and less electropositive elements are D block elements. So why MCQ number 40? Why is thorium included in F block elements? First, according to electronic configuration, according to physical properties, according to chemical properties, according to practical properties. So the right answer is according to practical properties. If we observe the electronic configuration of thorium, it is not compatible with F block elements. We can observe that thorium has electronic state have atomic number 90 and radon, then Z 7s2 62 and 5f0. If we talk about Aufbau rule or Madelung rule, so from that perspective there will be one electron in 6d and one electron in 5f, but in case of thorium there is actually no violation of that rule, because for thorium or any other element, apart from the perspective of stability, having no electron in orbital or zero or half filled or complete filled is a symbol of stability. That's why having zero electron, thorium have zero electron in 5f, but it is included in F block elements because of its practical properties or other practical properties. MCQ number 41 dash are first transition elements: AC, RT, AC, RE, RF, LA, YRF. So the right answer is AC, RT. MCQ number 42, the dash are included in lanthanide series: lanthanum to lutetium, cerium to lutetium, lanthanum to yttrium, cerium to yttrium. So the right answer is cerium to lutetium are included in lanthanide series. MCQ number 43 dash is the general symbol used to represent lanthanoid: Ln, La, Le, Li. So the general symbol is Ln. MCQ number 44 dash are included in actinide series: TH2LR, AC2LR, AC2NO, TH2NO. So the right answer is TH2LR. These are the elements are included in actinide series. 545 dash has very close similarity with lanthanoid: LR, cerium, lutetium, lanthanum. So the lanthanum has very close similarity with lanthanoid. MCQ number 46, lanthanide elements are separated on the basis of their difference in basicity, physical properties, chemical properties, difference in acidity. So they are separated on the basis of difference in basicity. MCQ number 47 is dash is the radioactive element in lanthanoids. Only one element is lanthanoid. In lanthanoid is radioactive, and that element is promethium. While lutetium, ytterbium, samarium are not radioactive elements in lanthanoids. MCQ number 48. Gas is used to produce very low temperature by magnetic field. Pyrophoric mixed metals uranium, thorium, gadolinium sulfate. So gadolinium sulfate is used to produce very low temperature by magnet. This is gadolinium. It has atomic number 64, mass number 157.25, atomic symbol GD. For integral number 49, F block elements have the following electronic configuration: n-1 F1 to 14, n-2 D0 to 1 ns square, n-2 F1 to 14, n-1 D0 to 1 and ns square, n-1 F1 to 14, n-1 D0 to 1 and ns square, and 4 is all the above. So the right answer is second, n minus 2 F1 to 14, n minus 1 D0 to 1 ns0 ns2. MCQ number 50. The general electronic configuration of actinides is given as red radon 5 F1 to 14, 6D0 to 2, 0 to 2 and 7 s square. Or the second one is radon 5 F1 to 14, 6D0 to 1, 7 s square. Third one is radon 5 F1 to 14, 6D0 to 3, 7 s square. And D is radon 5 F1 to 14, 6D0 to 9 and 7 s square. So the right general electronic configuration of actinides is second. MCQ number 51. The general electronic configuration of lanthanides is given as xenon 4F1 to 14, 5D0 to 4, 6s square. Xenon 4F1 to 14, 5D0 to 2, 6s square. Xenon 4F1 to 14, 5D 5D0 to 1, 6s square. Or xenon 4F1 to 14, 5D0 to 10 or 6s square. So the right answer is C. MCQ number 53 is the dash is the constitution of metals in pyrophoric mixed metals. We have already discussed this. The pyrophoric mixed metal contains 50% cerium, 40% lanthanum, 7% iron, and other constituents are 5%. MCQ number 54. The radius of La3 plus is 1.06 angstrom. Then what will be the radius of lutetium 4 plus? 1.61 angstrom, 1.42 angstrom, 0.85 angstrom, 2.06 angstrom. So the right answer is 0.85 angstrom. MCQ number 55. What is wrong statement for cerium? The general oxidation state of cerium is +3 and +4. +3 oxidation state of cerium is more stable than +4. +4 oxidation state of cerium is not available in aqueous solution. Cerium 4 behave as an oxidizing agent. So the right answer, the wrong statement for cerium is the general oxidation state of cerium is +3 and +4.